Hi everyone and welcome to The Router, the official podcast of the UQ Computing Society, where we explore the human side of tech. I'm your host Matt, and today I'm having a chat with Will Toohey, also known as @Mon on Slack. He currently works at Movis as a software engineer, but in his spare time he is a passionate rhythm game fan and hardware hobbyist. Today he's going to be telling us all about his experiences working on these side projects and how you can get into hardware too, no 4-year electrical engineering degree required. Welcome to the router, Will. How are you doing?
I'm doing great. How are you?
I'm all right. So I thought a good way to start would kind of just be like if you could give a bit of an intro about yourself.
So I'm William Toohey. I finished a software engineering degree from UQ a couple of years ago. Currently, I'm working for a startup coming out of UQ's iLab called Movis that works in predictive maintenance. And on the side, my major hobby is making and selling and manufacturing controllers for arcade games and interface things for arcade games and basically making PCBs and designing PCBs. And that's my hobby at the moment.
Oh, sounds good.
Side hustle, you could call it.
Side hustle, yeah. So that's interesting. So you only studied software engineering. So you didn't study computer engineering or anything like that? Just
Yeah, so I started doing mechatronics, but it turns out that I don't like the mechanical side of things. So I switched to software and aerospace because it seems cool, but the maths was too heavy, so I went to straight software.
yeah, fair enough.
But I focus mostly on the firmware side of things. I really get a kick out of optimizing software to make it run on constrained platforms and getting the most out of a piece of hardware.
So did you do a lot of like embedded systems programming kind of stuff at uni, that kind of thing?
I think the deepest I went, I didn't actually do embedded systems. The closest I went was CSC 2310, actually.
Oh, yeah.
And also CSC 3010, which I believe is the FPGA course.
Yeah.
And that was about the deepest I went. Apart from that, it's just applying standard software engineering stuff to embedded and making sure to optimize all the time.
Sounds good. So you mentioned PCBs. I guess to anyone who's so as someone who's not super into this kind of thing, I know that it stands for printed circuit boards, right? So it's the kind of like the green little things. You have all your circuits printed on them and all that. But could you maybe give a little bit of an intro to those like more software inclined people like myself, I guess, who kind of don't know what's involved in getting a PCB or printing one?
Yeah, so if you do, I believe, Team Project, there'll be a PCB component there. And it's effectively, okay, you've got your software on your computer, but you want something to happen in the real world. Maybe it's as simple as a keyboard. In my case, it's a slightly more complicated keyboard with a couple of knobs on it. But really, all you want to do is you want to attach those knobs to a controller that talks over USB to your computer and gets input into your thing. Or it could be a standalone thing, whatever you want. But it's effectively just designing a circuit that connects all the components together that you want to connect together and putting that all into a flat piece of fiberglass and making it easy to manufacture. And you stick it all together, and instead of having to wire up everything by hand, you just solder everything to the board and it's all connected for you.
Oh, very nice. And then like if you had like any like I guess IO or anything like that, you'd kind of just do that after the fact, right? Like on top of the board.
What do you mean by that? As in like connections to other things?
Yeah, so for like your rhythm game controllers or anything like that, you'd have some sort of like USB port or something, right? And you'd need
Oh, yeah. So you just solder on a USB port and you get a USB cable and plug it in. And as long as you haven't messed up your PCB design and everything's connected properly, you plug it in and you get that beautiful boop, boop, boom, and off you go.
All right, sounds amazing. And I guess like, yeah, so that would be like the next step after you have some sort of like a, maybe like an Arduino or something is when you'd first be your hardware
you
project.
always have to start with an Arduino on a breadboard because there's no faster way to prototype things, really.
And then PCB is kind of like the polished, finished version, I guess.
Oh, I've got several unfinished PCBs, I can assure you.
I know, unfinished or finished depends on the state of the project.
Definitely a lot less broken than wires all over your desk.
Yeah, I think like with the students who don't really go into do team project or anything like that, the most that software students get exposed to nowadays, I think, is really that breadboard kind of kind of thing from CSSC 2010 with all the like the tiny little cables that break and all that. So
Yeah, and I think CSC 2010 in particular, I think, is an absolutely fantastic introduction. If, for example, you're in a stream, is it optional in any streams? Because if it's
so if you're
optional, I
studying
recommend taking it.
yeah, if you're studying computer science or software engineering, it's definitely compulsory. So yeah.
Good.
Yeah, very good. I loved it as well. So another question I guess I had. So with these hardware projects, could you go a bit into? You mentioned rhythm game controllers. For the
Yeah.
uninitiated, what are those? What does that entail?
So if you're not sure what a rhythm game is, you might have heard of Osu, you might have heard of Guitar Hero, you might have heard of Dance Dance Revolution. There's music on the screen and notes that you have to hit in time to the music. And I got really into this rhythm game called Sound Voltex, which is effectively 6 buttons to hit with your fingers and 2 knobs to twiddle with your fingers. And it's quite unique, and it's very difficult to simulate knobs with a keyboard. There are existing controllers on the market, but they're massive. They're about $200 and an extra $150 in shipping. And I thought, I can do a bit better than that. I can make this smaller and a bit more portable. So I designed a small PCB, put on an Atmega controller, similar to the one you might be using in 2010, slapped on a couple of buttons and a bunch of encoders, made a PCB for it, and it actually worked fairly well. And so I started iterating on that and made it bigger because it was too small and too cramped, and slowly over the course of a couple of years designed this thing, posted about it online, and people thought it was pretty cool. So I made a bunch more, and I think I've sold about 300 so far.
Oh, very nice. Yeah, I'll make sure to chuck the link as well if anyone is interested in Sound Voltex in the description.
Cheers.
But so that's kind of cool. So how long did it kind of take to build the first version of that, like the first working prototype? Was it over like a one weekend of just like crazy prototyping, or was it kind of a long term
The first
thing?
prototype, actually, yeah, it pretty much was a weekend project. I just
Nice.
drew up, and I was using Altium at the time because you get to use Altium at uni. I just threw this thing together, drew up what seemed to be the right idea, put stuff on the board, sent it off to be manufactured by a random Chinese fab place, received it 2 weeks later, and there were a couple of problems with it. The USB connector, for example, I had wired incorrectly and had to hotwire some of the connectors to actually make it work. But yeah, you can really throw together a quick test PCB in a weekend easily. And if you get a bit more practice under your belt, in a couple of hours sometimes I can get a PCB just to test a concept. Because sometimes, even with breadboarding, I don't like breadboarding. It's a lot of effort to plug in all the wires everywhere. Sometimes I'll just design a PCB to make my life easier.
So I guess that like over that weekend you kind of used a lot of the like PCB design tools and things like that. How much of that was picked up from uni, and how much of it was stuff that you just kind of had to like muck around with and Google? Is it kind of like when you work on an entirely software project? No, at least for me, a lot of the time is spent just going on Stack Overflow and looking up very ad hoc solutions to the problems I kept running into and solving it that way. Was
I
it
can
kind of like that,
find
or?
in PCB design, at least for me as a software person, so I wasn't trained in electrical engineering. I don't know some of the more advanced electrical aspects of it. It's kind of a feeling, a intuition that you get for how to make things and not have any problems. So, and that just comes with practice. One of my initial designs, I accidentally had a ground wire that, instead of going from point A to point B, looped around the entire PCB and then got to point B. And when I got the board, sometimes when I was turning the knobs, the buttons would start turning on by themselves. And the board would start resetting if you spun the knob too fast. And without an oscilloscope, I just kind of looked at the board and eventually realized this ground wire was too long. I fixed that in the next revision and it worked fine. So electrical engineers probably have a bit more official teachings. I know that there were a couple of PCB design lectures in one of the team project lectures,
Oh yeah, yeah.
which definitely gave you kind of the basics. But yeah, a lot of it's just a wire needs to go from point A to point B, draw it from point A to point B. And
Yeah,
Stack Overflow is still quite useful. Sometimes I'm not sure, for example, USB. They say that you need to have differential pairs in that the wires need to be the same length. So I looked up the USB routing best practices on Stack Overflow, and the end result is a lot of the time it doesn't matter too much because the traces that you're making are maybe 10 centimeters long. The USB signals, to be good, can be somewhere within 20 centimeters of each other, which on a small PCB is huge.
20?
So
Oh, yeah, damn.
instead of looking up how to do stuff, you just look up some concept and then best practice, and Stack Overflow ends up giving you pretty good results that way.
I see, yeah. So, oh, interesting. I guess, like, for me, personally, these hardware projects are super intimidating because it seems like there's so many ways in which you can get things wrong, but...
I think the main mental block as well, yeah, there are so many things that can go wrong in PCB design. The main thing is just accept that everything's going to go wrong all the time. Eventually it'll stop going wrong because you learn. But things always go wrong. You just iterate and try again. Think about how many times you've hit compile on a C program and you've had a compiler, or how many times you've thrown some JavaScript onto a website and you've uncovered some stupid bug. The only problem with printed circuit boards is it costs you about $10 every time that happens. But things will go wrong. As long as you commit to actually iterate your project, you'll get there in the end.
I see. Do you have any recommendations, I guess, for those who want to get started? Like, so you need to find somewhere to manufacture these PCBs, to print them out. Do you have any recommendations?
So for the longest time, I've been using Seed Studio because they've been cheap and reliable. But recently, JLC PCB, along with, if you follow anyone electronics on YouTube, they advertise a lot. But thankfully, they actually provide a fairly good service. They're very, very cheap. I think it's $2 for a set of PCBs. Plus, don't ever forget the $15 to actually ship it to you. But the PCBs themselves are quite cheap. The traces are all quite nicely routed. The silkscreen is crisp. The silkscreen, of course, being the writing on the PCB that tells you which parts that go where. But there's a bunch. There's JLC PCB, there's Ella Crow, there's Seed Studio, there's a couple of others, and they're all fairly similar. The PCBs are under $5 if they're 10 by 10 centimeters. You get 5 of them, and they get delivered via snail mail.
Oh, so you get multiple PCBs.
Oh yeah, you always get 5 copies. So if you want to cut a PCB up and see what it looks inside, or if you want to completely ruin a PCB, if I've got some trace that is connected to a component, and I'm worried that if you hit this component too hard, the trace might come off, I'll just solder the component on and rip it off myself because I've got 5 more PCBs to test it with. And that way you get a really good feel for exactly how strong these circuit boards are, and they actually are quite strong.
So yeah, I get more opportunity for trial and error than I thought. That's cool. Yeah. And I will link that in the description. And just to clarify, we are not sponsored by any of those
I'm not
companies.
sponsored by any of these people.
No one. Yeah. just a word of mouth recommendation. But cool. I guess, were there any other projects that you kind of? I'm guessing that hasn't been your only project.
Yeah, if I go into my projects folder, I've got something like 30 different things in various stages of completion.
Any good stories? Any like?
Yeah. I've got. There's some interesting stuff with the Pocket Voltex, which is the Sound Voltex controller. The initial version, I wanted RGB LEDs, and I wanted them to be side-mounted, but side-mounted RGB LEDs didn't exist in a very convenient form. So I got these through-hole LEDs and bent the legs on them, but then I needed to drive them, and I didn't want to get an expensive controller chip. And it turns out that you can push an Atmega chip a fair way past its stated maximum limits as long as you do it infrequently enough. So if you've ever heard of multiplexing, it's powering something for only a small period of time. So if you have 60 LEDs, you power one at a time and you loop around and do them all in rows and columns. So I multiplexed the LEDs together, and an Arduino's pins, I think, are specified for a maximum of 50 milliamps per pin constantly. And I was able to push, I think, about 120 milliamps through the pin because I was only firing through that pin about 10% of the time. And that's the really good thing about being a hobbyist, is you don't need to worry about producing 10,000 of these or 100,000 of these. If you're doing something that's a bit naughty, if you can get away with it, it doesn't matter because it still works. So you can often drive things faster or use the wrong resistor, and it doesn't really make much of a difference.
So kind of going against like the super rigorous principles, but it's all right because it's your own little
throwing stuff at the wall and seeing what sticks.
Yeah. one question as a moderately curious software person with little experience. I've always been worried that I'm going to like fry my fingers or hurt myself in some way when playing with all these like electronics because I don't know what I'm doing. Would you say that it's at all dangerous, or if there are any basic safety precautions you would recommend for people who are messing around with hardware for the first time who aren't electrically trained?
There are really only two big things to be very, very, very afraid of, and that is 240-volt AC power and batteries that go into like drones or scooters or e-bikes. Those are very scary, and I would recommend staying away from them unless you're extremely comfortable with them. Everything else, it's all low voltage. 5 volt, 12 volt, there's not much that can happen. The worst things that I've done is you plug in your board, Windows says this USB port is using too much power, and you see a small little wisp of smoke rising from the board. And you realize something's gone wrong. Now, obviously, the first thought you have after that is to touch it and see how hot it got, but don't do that, because that you will burn your fingers doing that.
Yeah.
But apart from that, it's all such low power that it's very difficult to hurt yourself. You might stab yourself on a sharp pin more often than you'll hurt yourself with blowing things up.
Fair enough. So low risk as long as you avoid AC power from straight from the okay. All right. One last question I kind of had was about you mentioned you only studied software engineering, but you mentioned 2010 as well, 2310, 3010. Is there anything else you'd recommend if you wanted to learn about this kind of thing? Because for software engineers, right, and computer science students, we don't actually do the team projects anymore.
Oh, no, that's devastating.
Yeah, we do design computing, which is kind of more like a entirely software focused, kind of like there's like a game design thing and there's a thing like that. But would you recommend anything for those wanting to get into this kind of thing?
If there's any courses that are at all similar to Team Project, if you have to make something, that will be infinitely more useful than any other optional course that you could do. Because just forcing yourself to actually get hands-on, and as well being surrounded by other people who might know something that you don't, that's the best thing that you can do. As well as going to places like The Edge and South Bank, who always have a bunch of people messing on random hardware projects, or I think Hackerspace BNE has some very interesting things going on
I've
all
heard
the
about
time.
Hackerspace as well. It's like some warehouse or something, right, where with all the...
Because that was my real introduction to the hardware projects, was being lucky enough to be surrounded by all these smarter people than me at uni to get me excited about it.
Yes, that's basically it for me. I guess I want to ask if there's anything you wanted to say to anyone, any other advice or...
Oh yeah, there is one more thing I want to talk about actually. Get into Keycad. Keycad is an absolutely tremendous piece of software. If you haven't heard of it, it is a free PCB design software sponsored by the guys at CERN who did the Large Hadron Collider.
Nice.
5 years ago, it was acceptable, but not really great. It was kind of janky. They've last 8 months or so, they came out with a new version 5, and it is really a tremendous piece of software now. Completely lowers the barrier to entry. You don't have to worry about paying $10,000 for Altium. You don't have to worry about Altium's free cloud offering that means that if they ever go down, you lose all your PCBs. It's all local. All the PCBs are text files. Often I'll find a bug with Keycad where they won't let you do something, but you know it's technically possible. You can just edit the text file.
Oh, so that's cool. So this would kind of replace any like other kind of software, but
Yeah,
it's,
so if you've ever
it's
been-
text-based?
Well, you edit it using a GUI, but Altium, for example, even Microsoft Office, LibreOffice, no matter what you're looking at, if you try and open up a document in there, it's a bunch of XML files and zip things together.
Oh,
and
yeah.
it can be quite complex. PDF files, especially, are extremely complex. Whereas Keycad, you can look inside it and you can instantly understand, just as a human being, oh, okay, this is a piece of line on the copper layer on the top. And if you want to change the layer from f.cu, which is front copper, to back.silkscreen, if the GUI is too dumb to let you do it, you just modify the text file and reload the GUI, and it works because it doesn't really care too much.
Oh, that's cool. Is it? And this is all like open source?
Yeah, completely open source and Python scriptable as well. So if you have a massive PCB layout, I'm designing a keyboard that has 64 switches on it. In Altium, you might use rooms that let you do that, but I just wrote a Python script that laid out the board for me in a perfect grid. And every time I wanted to move one thing, it moved them all for me. Oh. And there's actually quite a community around making scripts for Keycad that let you do interesting things like that.
I guess that'd be kind of cool because it would cater to all the programmers, who just want to try messing around with scripts or whatever to make the
exactly
the little PCBs. Oh, that's cool.
Oh, and one last thing I wanted to say as well. If you are a programmer wanting to get into PCB design, one thing I've noticed about the small hobbyist industry is that it's full of people who don't actually know how to write code, but they're really good at the hardware thing. So if you can bring your programming knowledge into the hardware space, you can produce some incredibly valuable PCBs. You can make some gorgeous interfaces that connect your PCB to your computer. Maybe you want to make a really cool audio amplifier that no one's done before. Always look at something and go, if you need inspiration, look at a project that you use or a product that you use and think, can I do this better? Or even if you're starting out, just, can I do this? Try and replicate something. Put your own spin on it.
Would you recommend a rhythm game controller as a good...
only if you're into rhythm games. But if you are, it's quite fun because they're very simple. It's just a USB controller, buttons, maybe some knobs.
Basically a mini keyboard, right? Yeah.
Yeah, it's basically a small keyboard. In fact, that's also a good start. If you wanted to make your own 60% keyboard from scratch, you just make your own PCB. Put in a bunch of diodes, a bunch of switches, wire it all up. It can be quite therapeutic wiring a PCB.
Well, I guess there you go. Anyone who's listening, if you want to mess around with hardware, it's not as intimidating as you might think,
I basically live in the projects channel in Slack, so feel free to, if you want any help with hardware stuff, feel free to ping me. I'd love to give you a hand.
All right, that's it. #projects on Slack, and I'll link anything that was mentioned in the description of this episode so you can look into it further. All right, thanks so much, Will.
Fantastic. Thanks for having me.
All right, that's all we have time for today. Thanks for joining us. As usual, our next episode will be out in a fortnight. So until then, come join us on our Slack community at slack.uqcs.org or listen to past episodes of The Router at router.uqcs.org. My name is Matthew Lowe, and this podcast was created by the UQ Computing Society with gracious support from our industry sponsors.